This video is a continuation of our study of energetics to finish our discussion of ways in which the laws of thermodynamics are used to describe free energy. In reactions, we can study the equilibrium constant, or K, of a reaction. It gives a proportion of reactants and products at equilibrium for reactions that are reversible. In other words, it measures the net direction of a reaction, whether it is more forward or reverse. The equilibrium constant is the concentration of products over the concentration of reactants. We'll keep our discussion simple so that we're looking at only one set of reactants and product. In a living system, all reactions are much more complex. For known reactions, the ratios of concentration of products are predictable and determined by the delta G. We cannot compare energetics without considering standard conditions, which will be covered in just a moment. First, let's look at the equilibrium constant for generic reaction of converting reactant A to product B. When the two are at equilibrium, the K value is at 1.0. As the K value increases, product formation is favored. As the K value decreases below 1.0, reactants are favored. Trying to simplify this, an equilibrium constant of 1.0, we will have the same proportion of reactants and products. An equilibrium constant greater than 1, such as 4.0 in this scenario, products are favored. Lastly, an equilibrium constant less than 1, such as 0.25 in this scenario, reactants are favored. Getting back to standard conditions, these are represented by the degree symbol. These conditions are used in laboratories to control experiments, but do not always represent biological conditions. Therefore, we can use the standard conditions to have an idea of what to expect in a living system. These standard conditions are a temperature of 25 degrees Celsius, 1 atmosphere of pressure, a concentration of reactants and products at 1 molar each, a pH of 7, and a water of 55.6 molar. Standard free energy then takes into consideration the equilibrium constant, K. It's the negative product of the gas constant and temperature in Kelvin times the natural log of the equilibrium constant. Your natural question may be, what's the point of all this? Well, in a biological system, we can find that the relationship between the standard free energy and change and equilibrium constant are related and inverse. For a delta G that is negative, the equilibrium constant is greater than 1, and products are favored. A delta G of 0 has an equilibrium constant of 0, and the proportion of reactants and products are the same. Lastly, a positive delta G will have an equilibrium constant less than 1 and favor reactant formation. In summary, the equilibrium constant is inversely related to the delta G and can be used to calculate the proportion of products to reactants in a reversible reaction.